Hello, everyone. Welcome and thank you for joining today. My name is Bikram Gupta and I'm the product lead for containers here at DigitalOcean. Today's topic is very close to my heart and really excited to speak to all of you. Let's get started. We see thousands of clusters being created every week. One thing that we have observed that creating a Kubernetes cluster is really simple. All you need to do is to go to the Kubernetes console on the DigitalOcean cloud and just say click. You don't even have to configure anything and you get a cluster. But the challenge is when you start to deploy the applications in production. I like to give this analogy of running an application in a virtual machine versus running the same application in Kubernetes. In a virtual machine, your application runs on a single machine. If you need to troubleshoot, or if you need to find any performance issues, or even if you need to upgrade, you know that you can log in into that one machine and you can resolve the issues. In contrast, on Kubernetes, you have multiple replicas of the application. Those replicas are distributed on different machines. Over time, some of those replicas get restarted and gets rescheduled on different machines. And so in a day, you have so many changes going on that if you need to look at the logs or the metrics, you don't have a single place, you don't have a single node that you can log in and see all those things. And that's why the vanilla Kubernetes is hard. But with the right set of tooling and the right set of workflows, it can be really simple. At DigitalOcean, we like to call it day two operations. Given that Kubernetes is a distributed system, there are things that you need to be able to make it production ready. Things like keep your logs at one place, being able to mine through the logs, keep your metrics and the dashboards and the alerts and notification all in a single console. Being able to route traffic to tens of applications which are running in your cluster. Being able to take the backup and restore it when needed. We believe that all these things should be part of your cluster creation workflow. Now, the challenge is these things are hard. I mean, installing anything is simple. You can just do a Helm install and that works. But the thing is, how do you operate it? And what we have seen is that sometimes it takes weeks or months of time to come up to speed and get a production ready cluster. We think about this a lot and we have been spending time on this for the past few months. And so we created this thing called DO Kubernetes Starter Kit. Doc's Starter Kit is just a toolkit. You can use it as a tutorial and learn all the components, that is ingress, monitoring, logging, and backup, all these components through extensive tutorial. It is also an automation stack. It means you can actually deploy a production-ready cluster in just about 20 minutes. It is hosted in the GitHub. We have a team working on it and we constantly update it. And we are also active on the discussion channel in the GitHub. So if there are questions, you can actually discuss those. Let's go over the components of the starter kit. And it's always important to take a real life example and work backward. In a typical scenario, you are running more than one application on your cluster. And let's call those applications as Echo and Quote. So there are two applications running on your cluster. The first thing that you need is to expose those to outside the cluster. And for that, you're going to need an ingress. We have two options for the ingress. One is Nginx, which is of course most widely used. And one is Ambassador API Gateway, which is very popular, built on Envoy and very performant. Now, using an ingress, also you also have to configure the ingress appropriately. In our case, most of the time you want to expose using HTTPS. You want to do the automated certificate management, and you want to enable proxy protocol so that you can see the original client IP address. Now, once the ingress is done, your user traffic can actually hit the end applications which are running on the cluster. Then the next step is how do you monitor these applications? And for that, we use very, very popular kubeprompt stack, which is a combination of Prometheus, Grafana, and a lot of very useful dashboards and notifications. We customize the kubeprompt stack for the Prometheus to store all the matrix data in the DigitalOcean block storage. With the metrics, you can actually see the utilization, and you can optimize the required request and limits and CPU as needed. Then you have hundreds of users who are accessing your application. You also have all these components which are running on your cluster, and you need some way of seeing the logs that is all coming out of these components. And for that, we use Loki. Loki is a very interesting product which has become very popular in the last 2 years. And the good news is that it uses the object storage. In our case, we configure it to use DigitalOcean Spaces as the backend. Now, those of you who deal with logs, you know that the logs can get overwhelming very quickly. And so we have configured Loki so that you only whitelist the applications from which you need logs. And you also configure recycling of the older logs to keep your cost to minimum. The next component is Velero. Velero or Trilio are used for backup, and both are included in the starter kit. With the backup, the thing is that you really don't want to worry about it until you need it. So you want to configure your backup so that it's fully automated. You are collecting the backups, storing those in the object storage, which is DigitalOcean Spaces, on a regular interval. And you are also recycling, that is deleting the older backups. It should be totally hands-free. One last component is the sealed secrets. Basically, the entire starter kit configuration is stored in the Git repo. And our opinionated approach is to use GitOps for deploying applications to your cluster. And so when you are storing your application configuration in the Git repo, you'll also have to store the secrets or the credentials. And sealed secret is a mechanism to encrypt the credentials outside the cluster. So your configuration can still be in a Git repo. It could be public or private, but you can be assured that it is encrypted. Now, there are a lot of components here, but the good news is we have made it as a step-by-step tutorial so that you can actually go through it 1 hour or a few hours at a time. And now that you go through the entire tutorial, you also want to be able to automate it because you may be creating multiple clusters in a given week. And so we have a chapter which is automating the entire installation using Terraform and Flux. The way it works is that we use Terraform to bootstrap the Kubernetes cluster. And we also use Terraform to install Flux and initialize Flux. For those of you who don't know Flux, it's basically a GitOps tool. And in very simple language, it keeps watching a Git repository, and any change that happens in the Git repository is synced automatically to the cluster. So the source of truth of your cluster is always your Git repository. GitOps concept is very powerful because you can have as many clusters you want. You can have all your configuration is in a single Git repo and manage all of that from the Git itself. So once the Terraform and Flux are once Terraform will install the cluster and initialize Flux, then we wanted to give the control of the automation to you. It means you should be able to decide which of the starter kit components to install, and you should be able to decide how to customize. Because if you are using a 3-node cluster, you may need just one CPU for ingress, or 0.5 CPU for that matter. But if you're installing a 50-node cluster, you need to customize it differently, and you need more replicas. And so we wanted to make sure that you should be able to select and customize the components that you need. And the whole concept of GitOps works very well for that. So with GitOps, the configuration stays in the Git repo, and I'm going to show that in a moment. And Flux ensures that that configuration is synced onto the cluster. So to repeat, use Terraform to bootstrap your cluster, use Terraform to install Flux and initialize it. And once Flux is initialized, commit the required configuration that you need to your Git repo that Flux is watching. And then it's the job of Flux to install all the components and configure those components just like you've specified. So now it's time to look at the demonstration. Given that we have limited time, it's worthwhile to pick just one component and go through that workflow. So let's say that I have my Kubernetes cluster up and running, and I want to install Prometheus stack. With Prometheus stack, I also want to be able to customize it, and I want to be able to encrypt my Grafana credentials. So how should we go about it? The first thing that you should do is go to the automation chapter. In our case, because we are interested in installing the Prometheus, I'm skip to step 7 directly. And there are just 2 steps to it. In step 1, we are telling Flux on where is the location of the Prometheus Helm repository. And in the second step, we are telling Flux on which Helm chart to install, which includes the values file as well. Let me just show you in the terminal. So for a moment, I'm going to the Git repo here, which is basically synced with my cluster. And this is the Git repo, which is hosting all the configuration that my Flux is watching. And let's see that here for a moment. So if I list my Git repository, which is basically a CRD by Flux, I can see that Flux is watching this Git repository once every minute. So if I make any change to that Git repo, Flux will take that change and sync it to the cluster. So going back here, in my Git repo, you can have any structure. but it helps to have a proper structure that even you can understand better. So for our starter kit, we adopt a very standard practice. We create a Helm folder because all the installation are done using Helm. And under the Helm folder, the actual repository from which the Helm chart is downloaded is kept under here in the repository folder. The actual Helm chart, which is installed by Flux, is kept under releases. And all the encrypted secrets are kept here under secrets. And we use this standard format for all the components. So for Prometheus, let's start going through step by step. The first one is the Prometheus repository. And this is pretty self-explanatory. You can see that it's a Helm repository, which is a CRD that Flux is watching. And CRD is custom resource definition, by the way. And if there are, and Flux is downloading the Helm chart from this repository. Very standard and very simple. Typically, this won't change at all. And let's go to the Helm release. Helm release is again a CRD. And the things that are of interest to us are this part. You can see that this is taken from the Prometheus community Helm repository, which is, we have defined that earlier. And we are picking this version of Prometheus stack. And then we are saying that we have certain replicas and certain retries. And you can see that we are also installing additional service monitor to be able to monitor the Ambassador and Loki and Velero and all those components. And we are using only 5 GB of storage for metrics. And we are storing that in the DigitalOcean block storage. So even if your cluster was deleted, the data will not go away. You have to delete it manually or you can use it later. So as you can see, you can actually customize it. Even if you're using it on-prem, the only customization you need to do is modify this part because this is dependent on DO Cloud. The rest of the things are pretty much open source. The last part that I want to show you is you cannot have your passwords in clear text. And all of you probably know that secret is not a encrypted thing. It's just a base 64 encoding. And so the Grafana password is something we want to encrypt. So we are telling that, okay, you need to pick that up from this secret. How are we encoding that secret? For that, let's watch the secrets. And you can see here that it's a sealed secret. It's not a secret. It's a sealed secret CRD. And this is just a dummy encrypted thing. Now what happens under the hood is that as soon as Flux syncs all these resources to the cluster, there is a sealed secret controller, which is watching this CRD that will decrypt the string and create a secret resource. And let's see that in the terminal here. So we can see that we have a Prometheus stack credential, but we did not create it. And we definitely did not include it manually here, right? And so the source of that is, if I look at the logs of the sealed secret controller, I'll see that here you can see that it found for sealed secret is because using public key, it was able to decrypt. So I told you that it's all Helm. That Flux cluster. Let's see. Stack. And if you recall, I had this person earlier in that in the releases file. Now, if I need to make any change, all that I need to do is I have my current, I have already cloned my repo. And all I need to do is I need to make changes to replicas or whatever change I want to make. Or if I want to install a different version of the Prometheus stack, I just need to change that release version. And I should be able to see those changes in the cluster. Flux will do the Helm upgrade under the hood. Okay, so what we did just now was we took the cluster, we basically took the example of the Prometheus stack, and I just showed you how the starter kit does the actual automation under the hood. In real life, you will simply clone the starter kit and you will make a few changes that you need for customizing the components. And that's it. And once you commit to your Git repo, that should show up in your cluster. I should also clarify that you can do it on your existing cluster as well. All you need is download the Flux command line and then bootstrap Flux in your cluster. And then the rest of the steps are identical in the chapter 15 of the starter kit. To summarize, the power of Kubernetes can be leveraged if you have the right set of tools and workflows. Otherwise, it's really hard. And Doc's starter kit is an attempt towards that. It helps you to create production-ready clusters. And it's actually fairly simple. Even if there are a lot of components, you can manually step through all these lessons over a weekend. And once you are ready, the actual automation can be just done in less than 20 minutes. So try it out and feel free to use the discussion channel in the GitHub repo if you have any questions. And of course, I'll be watching the Discord here if there are any more questions. Also, I should say that the pull requests are welcome as well. With this, let's get to the Q&A. I see that there is one question from Crystal. Is there an alternative to Prometheus, as the metrics would require a lot of effort from the dev team? That's a very good question. And we know customers who are using things like Datadog, right? And so it depends on what's your choice. In the starter, Prometheus is very widely adopted in the Kubernetes community. And what we also have done is we have taken the dashboards which are available as part of the Kubernetes Mixins project and the default notifications and alerts as well. So getting started becomes really simple. If you have tried the starter kit, you'll see that it comes with about 12 plus dashboards. And you can start with the cluster-wide dashboard and drill down to individual namespace view or the application view or even the network view. And so based on my understanding, and I've tried this, I've done this as well, if you configure it appropriately, then adding the matrix to the adding the analysis for the new application is comparatively simpler with Prometheus. There's another part to it, which is your application ready for Prometheus to scrape the matrix? So for that, one is the default things that Kubernetes itself can scrape or the Prometheus can scrape, which is the matrix on CPU, memory, and all that. The other part is instrumenting your application with the appropriate library. You have to do that for matrix and tracing, and different vendors have different tooling. Hopefully that answers your question. Okay, are there any other questions? How are standard security monitoring components installed along with the normal application code? I'm just reading the question again. How are standard security monitoring components installed along with the normal application code on the node and pods? So this is quite extensive topic, right? When you say security monitoring, what extent? One is by default, are you putting the appropriate network policies? Are you enabling the appropriate Prometheus-based monitoring and creating the dashboards? And then finally, are you capturing for security monitoring? And I'm assuming that the question is for like Ingress, Prometheus, and we have our collecting the logs and metrics. I don't think we are installing any network policies to isolate the applications, but we are definitely leveraging some of the partners. But in the beyond the monitoring, any other question? Use the discuss issue problem, and looking forward to see you there.